We can review. So we continued our lecture over classes. Specifically, we talked about class constructors and how they help us initialize private data members for a class. We also learned about how C++ creates a constructor if we do not have any constructors defined in our class. So if we do not define any constructors, meaning if this line 11 and line 12 did not exist, then C++ would generate a constructor that looks something like this. And that allows us to create an instance of the class. However, once we create one constructor, then C++ will not generate the default constructor, mainly because it doesn't know if we need it or not. However, if we need it, we can go ahead and define it ourselves. We also talked about class constructor overloads. So for example, we can have one or more constructors as long as we have different parameters for each constructor. And as our classes grow, we will more than likely have more than one or two constructors. Okay, for example, the string class for the C++ standard library has more than two constructors, meaning we can create strings with a lot of different parameters. Okay. We also talked about the concept of a constructor that uses another constructor. For example, here, bank account, we had written some sample code that this could hypothetically, and we showed it could call the bank account constructor with a value of 0, and then that would be one simple example to show you how we can use delegating constructors. And as your classes get more complicated, the need for delegating constructors will definitely be there. We also created some examples to pass objects to functions. I will just show you the function header for that one. So we created free functions, meaning they are not part of the class. And we have a cons reference bank account that we use our own user-defined type. And then we can also have a class that returns our own user-defined type, right? I won't talk about the code there, but that's just to show us that we can work with our class and the key elements of our programming language C++. And then in the next lecture, we introduced UML, and we showed how UML can help a developer see how classes will interact with each other. We briefly talked about the this pointer. You can use it to make sure that the compiler knows that you are referring to functions or class variables, okay? And that's like when maybe there's like a name clash with a constructor argument or what have you. We also talked about the concept of static variables, right? So static variables will keep its value across the lifespan of objects. So for example, here we had 3 objects, and maybe initially the value of the static variable was 40, it increased to 90, decremented to 80, but just to show you that the static variable, I'm misspelling here, VAR, right? Oh well, will preserve its value across different objects, okay? And we showed that also with the test case where the sum of the bank balance in our example here, static integer bank balance, was the sum of all the bank account objects that we had created. And if we briefly just look at that code, and I'll scroll down to what I'm talking about, right? So all our bank account objects in these test cases, their total balance was 680, okay? And that was just to show you how static variables work, okay? And then we also covered friends of classes, and these are free functions that can access a class's private variable. For example, let me go find the code here, and we go to bank account. This friend display balance can access this private data balance. Okay, so if we go and look at the source code for this one, notice the difference here. We have a regular free function that is not a friend, display balance. We have to call the function get balance from account to get the balance. However, we have this friend function that can directly access a private data member of a class. Okay, main difference there. In addition, we skip member-wise assignment and enumerated tabs. We will cover them. And then we introduced object composition, or a class that will use another class, and we defined an ATM object that will use the ATM account. And if we briefly look at the ATM code, we went about it in a naive way just to show us how two classes can interact with each other. So the ATM can use display balance and leverage the bank account's get balance function to return the balance for the account, and then we can display the balance. Okay, very simple example. We will go ahead and in the next lecture introduce private functions. We will modify the ATM class. We will add a vector of objects to more or less simulate a real world application, and we will show you how we could initialize bank account objects, add them to a list, and at the same time simulate getting begin balance from the database with the C++ random function. We also introduced the concept of a friend class using a branch bank example. And then we go ahead and talk about explicit constructor, not necessarily default constructor, but we'll show you how there may be some code that it's not bad but may not be acceptable to a development shop, and then we use the explicit keyword. Finally, we will go ahead and talk about operator overloading. And what is operator overloading? Well, operator overloading is the concept of allowing our class to be treated like fundamental types, for example, like the integer, right? So we can say integer b equals 0, and then we can say cout b, and then it displays the integer. However, we cannot say cout account. We will get an error notification because there's no functionality to support this. So by using friend functions to overload operators, we will be able to handle syntax like that, and we will also be able to handle syntax like this. So we can say we create another bank account object A1, and we will be able to say, okay, I want to create another bank account object A2 that is equal to A1 plus account in A1. Notice right here it's flagging us for an issue because it doesn't understand what we're saying, but we will write some code to allow the compiler to understand that A1 and account can be added and give us a new bank account with the balance of A1 and account 2 and the A2 object. Okay, so we have a busy week ahead, so please finish reading chapter 11. We may get into the next topic, which will be we will get into inheritance, and then we'll talk about another access specifier, protected access, and we'll see how inheritance affects constructors and how it affects function overriding. Okay, not an extra R, right? Overriding, not overloading. Okay, so please go ahead and finish reading chapter 11 of the guidance book so that you can be prepared for the next topic. Okay, that's it. Thank you.